Coming live from the command center of the jwsolarusa. Guys, today we're talking about the Twin Towers, and on the previous video, part 4 of this series, you can see how I demonstrated how we balance the batteries by connecting the parallel on Tower 1 and Tower 2. So you guys seen all the process I've done here. See all the blacks, negatives there, all the way to the bottom. And we have an interconnect right there that connects the all the negatives. Okay, so it's right there. And we have all the positives all the way down. You see all the reds and interconnect here to balance the batteries. So what we're going to do today, we're going to test the voltage. After testing the voltage, if they're all balanced, and we're going to go about using these guys here. Like I mentioned, these were the Magnuson Magnum 1012. And these are powerful machines, the 1000 watts. There's a kilowatt, 12 volt. And they all have, this is manufactured 2018. See, after 2018 and the first quarter. And this other one is manufactured 2015, the first quarter. So 15, 16, 17, 18 is a 3 years differential. So what we're gonna do here, I have some few components. I was gonna show you what I've done, and I'm getting ready for this charging today. We test the battery first, then we're going to charge them. And what I've done since the previous test on the mini tower, Volkswagen mini tower right here, and I've done some modification. I'm going to talk about this on my next video, how I use the bus bars that I ordered for the Volkswagen e-Golf and to improvise it. If you go back and look at the videos I had before, on this one, you will see I have regular wires, and these are some of the wires I use to do the parallel and series. So I use one of the inverters to charge it, which is the 2015s. So now we're going to be using the 2018 to exercise the machine to see how it's going to handle this one old big bank charging it simultaneously. I can able to connect both of them to charge because they give a 30 amp out. If you look at it closely here, it's going to tell you the AC input is 20 amp and it gives out a 15 amp breaker, yeah, right here. So, and that's well if you use this outlet, the GFCI, want to power something. But we're going to be charging these batteries to see how far we can get these batteries all charged, or how many hours we can go about doing it. Like and subscribe, jwsolarusa. Thanks for watching. Okay, before we go further, what I've done, I have some of these wires I took out from the the Nissan Leaf battery when I assembling the Nissan Leaf battery. So these are the wires that came with it. And if you see here, there's just a small, it's not a 5/8, I think it's a 5/16 or whatever is this. And this smaller holes, they cannot fit to the terminals of the inverter input, DC input. So what I've done, I use this guy here, and I went through and just open up the holes a little bit. And I'll show you what I've done. And this is what I've done. Open it up with that tool. So it's kind of bigger now. So it fits exactly to the bolt. See that? It's in. So I kept the rubber bushing so I can be able to go like this, cover the terminal if I wanted to. But what I've done, I left the original part of it here, so I didn't even do any widening into this. So this is what we've been doing here, or this is what we're gonna do. and I just want you to be patient. It might be a kind of a little bit longer video, if you don't mind, but longer videos, they have a lot of story to tell. So if you want to watch, and go ahead and be patient and just watch exactly what I've done and how things are working here at the JW Solar USA, or how we do things here at the JW Solar USA. This is a good experimental channel. You know, we do things differently from others, and just like others does things differently from me or from us here. So what I'm gonna do, guys, I already have this bushing right here, so we're gonna use this one with one of the tie wire here, and use this as the negative here. Yeah, go about it. And we're gonna use this other guy for the positive. So we just have to be very, very mindful or very careful, so due to our polarity, so we can cause any arc or miswiring, or else we're gonna be in so much trouble. Trouble in the sense, you know what happened when you get in trouble with electronics. They burned out, or you just killed them. You destroy them. So guys, anytime you work on electronics or high voltage or low voltage DC, just if you have anything in your mind, you know, disturbing day, it's not a good day, I would advise you, take this from me, don't do the job. Don't try to do any electronic job or any mechanical job or any operating machinery. That's a rule of thumb. Don't do that, because what's going to happen, you're going to end up getting so much trouble. Things you don't want to happen, they will happen. And because your mind is full of everything and you can't concentrate, you have divided mind, and what's going to cause destruction, and it's going to cause life. You're going to lose your life or someone's life due to, I'm not saying negligency, it's just due to too much things in your mind or on your mind. So see, we utilize everything here. We don't throw everything. See the bushing right there? So we're going to utilize and just cover this thing, and the terminal is all protected. If something has to be fallen on this particular device, or maybe whatever, you have pets or something, mess around, just goof around, and or maybe just anything can happen, it's protected. You got a boot right here, just like the original ones. They have the boot right there. And this is what you do. You have to remember and be creative and be careful. So this guy is going to be plugged to the wall directly. I'm not charging this using my solar equipment. I'm using the grid to do this. Okay, it doesn't make sense for me to drain my batteries just because I want to charge these batteries. That's no sense at all. So let's use the grid today and burn some power. Like and subscribe. All right, before we go further, this is where we're going to be connecting the wire, because you want to charge the batteries in the opposite direction. This one tower, which is tower 2 and tower 1, so we're going to tie it into one of the tires opposite direction by using a number 10 wrench to do the job. Number 10. If you can only focus there, it doesn't matter anyway, but you guys know what I'm using. 10 right there. And I'm going to tie it, the positive on this side here on the other bank. So that's how we're going to charge it. But before we go further with all these process, let's take a look of the numbers that they were here when we started. This is tower 1. This is the one that we've been operating with for a very long time, approximately one and a half, 2 years now, and was sitting. It was on the solar. I took it off with the Volkswagen, sorry, with the Ford Focus, and it was reading 14.68 volt. These are the new ones that came, or these are the ones I received, not brand new, but it came from a 2015 vehicle. But the batteries are 2014s. I think they're manufactured a year before the vehicle. So you can see right there 2014. But I have, the bottom one is 2016s. So this is the voltage we started with here. It's 14.22. So we suck the power by pairing this thing here to do the job. And we suck the power to transfer from here, the highest, to the lowest, because anytime the lowest is the one demanding, it's transferring the power right there. So what we're going to do, we're going to use our Fluke 101 meter and this guy here, and we're going to test each tower to see the voltage that they already sit on. All right. And when let me go to this. So we started the balancing I think a couple days ago. So we're running the batteries at we started at 1848. So guys, so now we are 2026 the time, 2 days later. So when I connect these 10 minutes, when I connected the towers parallel them, and it drops to 14.45 from this both towers now are reading 14.5 within 10 minutes, and you end up going up to about 1450. So let's cut the talking and test these things here. So let's check tower 1. We're gonna come here, get this guy hooked up here, make sure we have it it's attached down there. Okay, now we move from here to here, which is tower number 1, and we already have tied into the positive over here. It's still reading 14.51. So both of them are parallel, or they are equal now, the voltage. So what I'm going to do, I'm going to take it from here to the other side there, and which is the parallel links, having both towers parallel or linked together. That's the same voltage, perfectly balanced. So it took, if you subtract 1468 out of this guy 1422, then you will know the voltage, how many millivolts. So they are sitting, they dropped this 1468 to 1451. See that? So it took some voltage out of here. Okay. Took the voltage out of here to make this voltage. 68 and that. So I think it's still balanced. If you see there's a 2 coming there, it goes off. So guys, we didn't give them the 1 week as we planned, so we decided to go about it. So let's tie these terminals here and get these bad boys ready for the show. All right, like and subscribe. We're gonna disconnect this because we're gonna tie the negative wire right here to here. Stay tuned. Now we have the negative side already linked. Take my probe out and they already connected. One of the inverter negative is already here. So we're gonna come over here and do the same thing. Connect one of the positive cable from the inverter. This one here. See the red boot right here? It's gonna tie up here. All right, stay tuned. But before we do that, we have to connect the the meter. I mean the monitor, which is this guy here. So this is the Magnum monitor. We're gonna plug this because we have to set the battery's specifications. So we're gonna get the connected right here, and Magnum has made it even easier to use the blue part of it. Connect just like a phone jack. Okay, you can't miss that at all. There you go, snap right there. It says remote. So we're gonna have these remotes plugged in. Plug this one here and it's ready to go. And we're gonna do setting up the parameters of the batteries, how we want them to charge, and then we're gonna plug the batteries, the machine, to the grid. I hope you find this video helpful. Like and subscribe. jwsolarusa. Thanks for watching. Alright guys, make no mistake, like I had mentioned earlier. So we're gonna take this one out, the parallel link, and we can add the inverter power inverter cable, which the monitor over there is gonna leak. Okay. You always have that little arc. Now the inverter started powering up. Keep it this way. Can put a lot of strain in the weight of it. Okay, so we got this guy here pretty much, and we are done here. So let's check this out. The voltage we had earlier, 14.51. The inverter is reading the 14.6. So we might probably need a calibration on this. So we can go back here and set up the batteries. So it's asking for search mode. We already have that, and absorb time, thing, battery type. You go custom, and that's what we want. It reads at 16 volt. That's what the batteries are, at 16 volt. They're all the same. So even if I try to bring this one down, it's not gonna go because the equalizing is off. Right? Like and subscribe. jwsolarusa. Thanks for watching. Alright guys, here comes the fun part. We're gonna program the battery capacity. How much amp hours? So 600 amp hours on each tower. Tower 1, tower 2. So it's 1200 amp hours we are playing with here. It's very, 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 very dangerous. So we go into the settings here. We want to look for BMK, battery monitor kit setup, and it's gonna say we're gonna leave it on auto, and to check the efficiency, it determines the efficiency for us. And we're gonna go to amp hours here. So the default is 200 amp hours. So we push the enter and dial this thing all the way. It's gonna be long going. You want to keep doing this till we get to the 1200. So the machine will know exactly what's the total amp hours of the battery bank before, so that we can able to charge it. So 1200, there you go, 1200 amp hours. So push enter, it's programmed. Now it's gonna recognize that it's 1200 amp hours. This battery is the capacity of it. So we had to charge it to make sure it reached the 1200 amp hours. So we've done with that. We leave it on auto. If you want to tweak the thing, do the efficiency. Some people like to go about this and set it, if you know the battery manufacturer efficiency, and you can just set it to 97 is the highest efficiency. So you can just dial it back to 50 is the auto, go auto right away. So we'll keep it auto, so the machine will determine the efficiency of the battery, was how effective they are or how much power they can handle. Since these are not brand new modules, it's used already, so they already have some degradation on it. So we have to make sure that we leave it in auto, let the machine determine what power needs to be entered to the system. So we set this one back. Now we're gonna make sure we plug that to the wall right there. Okay, that's the one of the outlet for the grid that is not connected, it's not on solar. Stay tuned. Now we already have it plugged. You see the flashing lights right there? So it's gonna do the auto connect. Now it's connected. So say charging, and we're gonna be throwing power back to the batteries here and see how much we can charge these batteries today. So this is how we go about charging the batteries. It's flow charging, because I think it's seeing the voltage of the batteries higher. Is I think it's probably past the nominal voltage. So now it's waiting for syncing. Then it's gonna start putting the power back to the battery. Like and subscribe. jwsolarusa. Thanks for watching. If you find this video helpful, give it a thumbs up. There we go. It's cranking now. Well, the thing is, that outlet is just a 15 amp. I wish it would have been a 20 amp. Then we can go here. You hear the fans? Then we can tweak it. See, that's the low battery cutoff. It's going to be a 12.2. That's the highest it can go. 12.2, you can set it that way. Or you can go lower. Some batteries you can be able to deplete all the way. So I set it on 13. If I keep it all the way 15, I'm going to trip the breaker. And the amperage is supposed to be ramping up here, since we're on 15 amp. But remember, the breakers are 15. See, 15 here and 20. See that? So the input can take about 20 amp. The output is 15. So I don't think it's going to make any difference now. And we're charging the batteries. You can hear the fan. Cool air coming out. So this is how we charge the batteries, guys. We put in some power into these babies, and we'll see how far we can bring them up. And from there, we are done. And that's the time we're going to be linking from this side here, the negative, to the tower here. We're going to flip this tower the other side. This side is going to be back here. Then we're going to have it interconnect wire that gives it a series 12 volts to 12 volts here, with negative to positive. It gives it to output here. We're going to take it from the opposite directions as well, and we're going to have the 24 volts, and we're going to be running it onto that system right there. Like and subscribe, or we're going to run another system. Stay tuned for something special coming in between that spot right there. Okay, so we're charging. So we start our charge at 20, let me just take it 2050 hours. 2050. So it's 8:50 here in Minnesota, Central Standard Time. So yeah, we're charging the batteries. Okay, thanks for watching. Love you guys all. Bye for now. Quiet inverter. You hear that? really quiet. It's charging. The same thing if it's taking power as well. This one, the 2015, is kind of a little bit louder than this one, little bit decibel, but this is way quieter. Alright guys, I decided to give you guys this bonus, and the bonus is I took this one offline so I can connect the 2015. So can you hear the decibel, the noise of the fan compared to the other one? So you will hear the 2018 here, 2018 as a 2015 right there. The 2015 a little bit louder, the fan. So I just want to make the comparison. That's why I disconnect and trying to show you guys. So I think if you want to buy, trying to check the year, the more recent model, I think the fan is more quieter. So it's pretty quiet. It's just like a fan coming, just a regular blower. But this way you can hear the wing sound on it. So it might probably bother some people. Some people are okay with that. Depends where you have it, but where you position it. So I decided to throw this little piece there so that you can able to hear the difference, do the comparison, which one sounds better. But I connected to that one right there, and it's still charging as well. Like and subscribe, JW Solar USA. Thanks for watching. See you on the next video.